All right, this is the second section of Chapter 1, adding and subtracting real numbers. So our objectives for this chapter are going to be adding real numbers and subtracting real numbers. You might be wondering, why real? I mean, are there numbers that aren't real? And the answer is, yeah, actually there are. There are numbers that are not real. They're called unreal numbers, or complex numbers, or imaginary numbers. And we are not going to be directly dealing with those numbers in this class. You will work with those in Algebra 2, pre-calculus, calculus, etc. However, it is important to know that, yes, there are numbers that are real, and there are numbers that are not real. And so it is an important distinction, and that's why they put those in there. In this class, this year, we will not deal with unreal numbers. However, we need to know that they're out there. And so we will, from this point on, assume that all numbers we're working with are real numbers, and we're going to be looking at adding and subtracting those real numbers today. Okay, so the first thing we're going to want to look at are a specific set of real numbers called the integers. Integers are the set of whole numbers and their opposites. So I know you're familiar with opposites, up, down, left, right. And so on a number line, opposites are like 2 and negative 2. So I'm going to put that down here, 2, and negative 2. Those are opposites on the number line. And, I don't know, maybe negative 7 and 7. Those are opposites on the number line. We have another name for those. We also call them additive inverses. A longer name, but additive inverses are the numbers that are the same distance from 0. And that's a little bit different than what some of you are thinking. Some of you might already be thinking about absolute value. We'll get to that later. But additive inverses, what that means is if you add them together, additive inverse, if you add them together, well, 2 plus negative 2, 0. Negative 7 plus 7, 0 again. In fact, additive inverses are going to sum, they're going to add to 0. And that's what makes something an additive inverse. And those are opposites of each other. So additive inverse are opposites. And that's what we want to keep in mind. And when we're trying to remember these specific math terms, additive inverses are opposites of each other. They add to 0. All right, moving on here. Finding the additive inverse. So I'm going to have you pause it. Find the additive inverse of all three of these numbers, and then we'll do it together. Okay, I'm going to assume you paused it. The additive inverse of 6, negative 6. Done. That's it. That's the only answer. You don't have to put plus. You don't have to put equals 0. It's just negative 6. That's all it is. That's the only answer. So the additive inverse of 6, negative 6. Additive inverse of negative 14, 14. That's it. That's all you have to write. So don't do any more work than that. That's all you need to have. And the additive inverse of 0.5, it is a decimal, and that's fine. It's still negative 0.5. Because 0.5 and negative 0.5, the sum would still give you 0. All right, so that's additive inverse. Not a whole lot of work there. Addition rules. We're going to be looking at adding, as we mentioned in the objectives. So there are some different rules that we have for addition. If they're smaller numbers, like let's say, 5 plus negative 7. You might be able to picture a number line and figure out what 5 plus negative 7 is. And that's great if you can do that. Or you could use your fingers and get negative somehow. But with smaller numbers, we don't always need rules to work that out. However, if you get some bigger numbers, let's say, 741 plus negative 502. That's a little harder to picture a number line. In fact, making a number line for that would be a waste of time. And so we have these rules to try and help us with that. And so what we're going to do is we're going to be looking at those signs. They have different signs, so like 5 and negative 7, positive 5, negative 7. Those have different signs. So we are going to follow that set of rules. We're going to find the difference. Different difference. To line up different signs, we are going to find the difference. So 5 and 7, the difference of 5 and 7. I'm going to do a little scratch work over here. If I find the difference of 5 and 7, 2. Okay, so I know that the answer has got to be 2. Now I have to decide, is that going to be a positive 2 or a negative 2? And that's where this battle of the signs thing comes in. Battle of the signs, you may have heard it referred to as something different, but we'll go with this. Battle of the signs means that we're looking at the two numerals, the 5 and the 7. We're not going to worry about the signs yet. We're just looking at the 5 and the 7. Whichever one's bigger, so 7 in this case, 7 is bigger than 5, that's the sign that we're going to use. And so since 7 is negative, the answer is -2. So we found the difference, 2. To decide if it's positive or negative, we're going to play that battle of the signs. Since 7 is a bigger numeral than 5, we're going to use the sign that 7 has. It's got a negative sign, so the answer is negative. Let's look at the other example. 741 plus -502. Again, different signs, positive and negative. And so I'm going to do a little bit of scratch work over here. I'm going to find the difference. Different signs, find the difference. Different difference, different difference. That should start to get annoying after a while, but it'll stick in your head. So we're going to find the difference if they have different signs. 741 minus 502. You'll notice my smartboard's a little calibrated, but so if I subtract it, I'm going to have to borrow. So I'm going to get 3, 11, 11 minus 2, I'm going to get 9. 3 minus 0, I'm going to get 3. 7 minus 5, okay, so 239. So I found the difference. Got 239. Now I have to decide if that's going to be a positive 239 or a negative 239. Well, I play that battle of the signs, looking at the number 741 and the number 502. 741 is bigger. Even though it's got that negative over there, 741 is definitely bigger. That is going to be the sign that we choose, which means it is going to be a positive result, 239. And that's how we deal with different signs when we're adding. Same sign. Same sign is a little bit easier, actually. Let's say we have, we'll go with -7 and -5. So if we're adding -7 plus -5, same sign. We're just going to add the two numbers together. 7 plus 5 is 12. And we're going to keep the sign the same. Some of you are going to mix this up with your multiplication rules. Don't do that. If it's addition, we add and we keep the sign the same. A negative plus a negative is negative when we are adding. Do not confuse that with multiplication rules. Different operations, adding and multiplication, different rules. So it ends up being a -12. If you are -$7 and you borrow $5 more, you now owe $12. So that makes sense. And it works, of course, with same sign. If you have, let's say, 741 plus a positive 502, nothing changes here. Same sign. We're going to add them together. And so we're going to get 1,243. And we are going to keep that positive because both have the same sign of positive. So those are the rules. What I'd like you to do is I'd like you to take a second here, pause the video, and add these two fractions together. Okay, I'm going to assume that you try both of these problems, and so I'm going to work through them with you. They're both positive, which means that we're going to add them together and keep the sign the same. They're the same sign, positive. And so if we add them together, they already have a common denominator, which is very nice. I can keep that 5. And then I'm going to add those numerators, 1 plus 3, 4. They were both positive, so I keep the sign the same, still a positive answer. And I cannot reduce that. 4/5 is as simplified as possible. I have my answer, 4/5. Same thing with the next one. Now with this one, of course, we're still looking at those signs. They have the same sign, so we're not going to find the difference. They have the same sign. We add them together. We do, however, need common denominators. So I think if you run through your list, you'll end up at the smallest common denominator that we can find, the least common multiple, 63. And so we'll get that common denominator there. If I did 7 times 9 to get 63, I've got to do 4 times 9, so I'm going to get 36. If I did 9 times 7 to get 63, I have to change the numerator as well. 2 times 7, that's going to give me 14. I'm adding these. I have that common denominator now, so I'm good there. If I add my numerators together, I should get 50, right? Yeah, 50. And I don't believe we can reduce that. Again, we had the same sign, so we keep the sign the same. Positive 50 63rds. All right, again, we've got subtraction. Now with subtraction, we have to do something different. We have addition rules. We do not have subtraction rules. So we are going to have to do something extra here. When you have a subtraction problem, rather than making up all new rules for subtraction, we're just going to change it. Instead of a subtraction problem, we're going to change it into an addition problem. And to do that, we're going to do keep, change, change. You maybe heard it as something else, but we're going to go with keep, change, change. We're going to keep the first number the same, change the sign on the change the sign to a plus. We're going to change the sign on the second number. So we're going to keep the first number the same, change it to an addition problem, and change the sign on the next number. We now have 3/7 plus negative 6/7. You should have seen this before in past years. Now that I do that, I'm going to want to follow those addition rules. So I have an addition problem. Those addition rules, again, if they have different signs, we find the difference. Different difference, different difference, different difference. So if they have a different sign, we're going to subtract those two numbers. I have common denominators already, so I can keep those common denominator of 7. The difference of 6 and 3, well, 6 minus 3 is 3. And if I play that battle of the signs, I see that 6 is bigger than 3, which means that I'm going to use a negative to speak of the answer. And so we've got a negative 6. 6 is bigger than 3, so my answer is going to be negative 3/7. And that is as reduced as I can get it. The next one here. Now with this one, if you did this, you may have gotten lucky. However, you cannot, or should not, maybe is the better way of saying it, just subtract the whole numbers, 2 minus 5, and then subtract the numerators, 3 minus 5. That is going to run you into some trouble later on. You might have gotten lucky with this problem. However, most of the time, it will not work out well for you. So I want to warn you, don't just subtract the whole numbers and then subtract the numerators. If you're dealing with mixed numbers, the best way, the only way to guarantee a correct answer every time, if you do it correctly, is to change it to an improper fraction. If I multiply the denominator times the whole number, 8 times 2, and add the numerator, 8 times 2 plus 3, I'm going to get 19/8. Same thing here. 8 times 5 plus 5, I'm going to get 45/8. And now I'm subtracting. But again, I don't have any rules for subtraction. So I'm going to have to keep, change, change. I'm going to keep the first number the same. I'm going to change the sign to an addition. I'm going to change the sign on the next number. So if I do that here, I'm going to end up with 19/8 plus negative 45/8. Now I can use my addition rules. They have different signs, so I find the difference. Different difference, different difference. 45 minus 19, I'm going to do a little bit of scratch work over here just to make sure my mental math is correct. So I'm going to subtract. I'm going to find the difference. 5, I can't do 5 minus 9. I got to borrow. So I've got 15 minus 9, and I'm going to get 6. 3 minus 1, I'm going to get 2. So I got 26 as my result. Eighths, keep that denominator the same. That's nice. Okay, now I have to reduce. Okay, so how many times does 8 go into 26? Well, I could do it that way. In fact, I will since I already started. 8 goes into 26 because it's division. We did mention that yesterday. A fraction and division, same thing. So 26 divided by 8 is what I have listed here. 26 divided by 8, I'm going to get 3 with a remainder of 2. You get 2/8 left over. You can double check that by changing it back. 8 times 3 plus 2, 26. Now we can write that in there. 8 times 3 plus 2, it does work back and gives you that 26. Okay, so we have our mixed number. Now we need to reduce. I can divide both the numerator and the denominator by 2. And I'm going to end up with a final answer then of 3 1/4. A lot of work, but all steps that you can do. And now I have to look and decide, is that going to be a positive or a negative? So if I go back a little ways here to this step right here, I've got a positive 19/8, and I've got a negative 45/8. Okay, well 45 is bigger than 19. So if I play my battle of the signs, 45 wins, it's going to be negative. So all the way through here, we have a negative 26/8, a negative 3 2/8, and then my final answer, a negative 3 1/4. That's my final answer. Make sure that in the process of all these fractions and all this reducing, you don't forget that we're still dealing with negatives. And so we have to ask that final question. Is this right? Should it be positive or should it be negative? In this case, we have our answer. Okay, so I'm going to pause it, or I'm going to let you pause it. Try these two. We got some decimals, and then we'll work at it from there. Okay, we did a few of these in class already, I know, but just to rehash it, remember to line up your decimal points when you're adding. So when you're doing addition problems, you are adding, or you are lining up those decimals. My smartboard is not cooperating as well as it should. I'll try that one more time. Here we go, 0.86, and we have 4.587. So we have 86 hundredths and 4 587 thousandths. Remember, you can always add zeros in to fill in any holes that you have. Add straight through. We're just going to add straight down just as if the decimals weren't there. We got 7, we got 14, carry the 1, and we got another 14, carry the 1. 5 and 447 thousandths should be our answer for that. Remember, that decimal point just comes straight down then. They had the same sign, so we added them together and kept the sign the same. We have our final answer, 5 and 447 thousandths. Again, I went back to check. Should it be positive? Should it be negative? Ended up being positive. Next one here. We've got 2 and 784 thousandths minus 1 and 3 hundredths. Now, in this case, you could do keep, change, change. You could change it into an addition problem, and that would work just fine. However, this is an advanced class. I'm going to make you think a little bit harder and do less work. If it's a bigger number minus a smaller number, you're probably okay just subtracting as normal. If it's a smaller number minus a bigger number, if it was reversed, then you'd want to do your keep, change, change. You'd want to be very careful of that. However, again, I'm going to rely on you to think a little bit harder, and then you can do a little bit less work. If it's a larger number minus a smaller number, you can probably set it up as you normally would, as just like that. Then you can always fill in with some zeros if you need to. We're subtracting, so 4 minus 0, 4, 8 minus 3, 5, and we have our final answer. I have to look back. Is this going to be a positive or a negative? Well, it was a subtraction. If I did do my keep, change, change, 2.784 is bigger than 1.03, and so it's going to be a positive answer, which does make sense in the way that you've probably been subtracting for a long time. Moving on here, absolute value. So the absolute value of a number is different than the additive inverse. Going through this fairly quickly because I don't want to run out of time on YouTube. So an absolute value is how far from 0 something is. It's just the distance from 0. You can't have a negative distance. You cannot walk a negative distance. You can walk backwards and you can walk forwards, but you can't walk a negative distance. You'd be walking inside of yourself somehow. It would be really weird. And so we cannot have a negative distance. So the absolute value is not the opposite. The absolute value is the distance from 0. So if you look at this first one here, negative 5. Okay, negative 5. Well, negative 5 is right there. I want to know how far from 0 is negative 5. Now let's see, 1, 2, 3, 4, 5. So the absolute value, these vertical bars here mean absolute value. The absolute value of negative 5, 5. It's 5 away from 0. All right, let's look at the other one. The absolute value of 5. Again, these vertical bars here represent absolute value. And so the absolute value of 5, again, we're going to find 5. There it is. And we're going to see how far away from 0 is it. What's the distance? 1, 2, 3, 4, 5. So the absolute value of 5 is 5. We have the absolute value is not necessarily the opposite. Absolute value of negative 5 was positive 5, but the absolute value of positive 5 was also positive 5. So you have to be very careful of that. It's just the distance from 0, and it will always be a positive distance. Additive inverse, if you look back in your notes to the first page, additive inverse, that's where you're looking at the opposite. Be very careful of those two. They sound similar, but very different results. Okay, so take a second, pause the video, see if you can do these two on your own. All right, let's give it a shot here. Absolute value again. So absolute value of -8. Since it's one number, I can take the absolute value of -8. The absolute value of -8, +8. -8 is 8 away from 0. Absolute value of -5, well, we just did that. -5 is 5 away from 0. We can add those together. 8 plus 5, that's going to give me, what is that going to give me? 13? There you go, 13. Done. Got my answer. For B is a little bit trickier. We don't have an absolute value with one number in between. We can't do the absolute value of 5 minus the absolute value of 6. That's not really what's going on here. What it's asking is, what's the absolute value of 5 minus 6? And the only way to really get that is to figure out what 5 minus 6 is. And so 5 minus 6, that's not a bigger number minus a smaller number. So I'm going to have to do my keep, change here. Some of you will already know the answer, but I'm going to go through this process. Keep, change. So I've got 5 plus -6. Now they have different signs. Different difference. I'm going to find the difference. So the difference of 5 and 6 is 1. There's 1 in between. So that's the difference. Battle of the signs. 6 is bigger than 5. So I'm going to keep that sign with 6. We've got a -1. And those absolute value bars have not gone anywhere. I still have those absolute value bars there. So now we've taken 5 minus 6. Now that we have one number in between those absolute value bars, I can take the absolute value. Absolute value of -1, -1 is 1 away from 0. Our final answer of 1. So if there's one number in between the absolute value bars, like in this case here and in this case here, go ahead and just take the absolute value. If there's more than one absolute number in the absolute value bars, you have to figure out what that is first before you can take the absolute value. All right, these are the last couple of problems here, and then we're done. Go ahead and pause it and try these three on your own. All right, here we go. So, first one. Again, we've got more than one thing in between the absolute value bars. We've got the absolute value of 4 minus 6. So before we can take the absolute value, we've got to figure out what 4 minus 6 is. So if I do my keep, change, 4 plus -6, and I'm going to get different signs again. So we find the difference. The difference of 4 and 6, 2. 6 minus 4 is 2. And we have that -6. So the 6 is bigger than 4. There's going to be a -2. Absolute value bars have not gone away. They're still there. Plus 8. Also, I've not dealt with the 8 yet. It's still there. Absolute value of -2. Well, -2 is 2 away from 0. Plus 8. 2 plus 8, that I can do, get 10. Final answer. For the next one, we've got 42 minus the absolute value of 5. Now, in this case, I already have one number in between those absolute value bars. So I can go ahead and just take the absolute value of 5. Remember that it's not the opposite. It's not -5. Absolute value of 5 is 5. It's 5 away from 0. 42 minus 5, we can do that, and we're going to get 37. Again, it was a bigger number minus a smaller number. I did not really need to do keep, change. I could just subtract. You can use your fingers if you want to do that one. You don't really need to do the keep, change when you have a larger number minus a smaller number. Last one here. Absolute value. We've got that 4 next to the absolute value. It's a little bit weird. It's different than we've seen in the past. So I'm going to do a little offshoot here. The absolute value bars act very much like parentheses in a lot of different ways. It's a way to group things. And so if you had 4 parentheses, -7 minus 2, and this answer will be a little bit different, but if you have those parentheses there, we'd subtract, and we would get a result. And then whenever you have a 4 or a number in those parentheses, that's multiplication. And so it's going to be 4 times, even though there's no multiplication symbol in here to show that it's multiplying. It is multiplication. So it's 4 times whatever is inside those parentheses. Going back to our problem, though, we've got 4 absolute value bar, negative 7 minus 2. So just as the first problem, just like C, we need to get those absolute value bars just around one number. So we're going to do negative 7 minus 2. It's a subtraction problem. So I'm going to want to do keep, change, change. Change it to addition, change the sign of the next number. Now I have negative 7 plus negative 2. These do not have different signs. These are the same signs, negative 7 and negative 2. They have the same sign. Remember, we keep the signs the same. So we're going to add those together and keep the sign the same. 7 plus 2 is 9, and I keep the sign the same. Negative 7 plus negative 2, negative 9. Absolute value bars are still there, and the 4 is still there. Now I can take the absolute value of negative 9. Negative 9 is 9 away from 0. Done. But I can't just put 49. That would be wrong, right? I mean, it's not 4 and 9. It's not 49. It's just like back here when we were looking at the parentheses. It's really multiplication. And so I'm going to go ahead and I'm going to put some parentheses here just to remember that it's multiplication. You don't have to put parentheses, but once you've taken that absolute value, if you'd like to put parentheses around it, just to remind you that it is multiplication, that's not a bad idea. Not necessary. However, you do need to remember that it's 4 times 9, which gives us 36. And that's our answer then. We've got 36 as our final answer. Okay, that's our notes for this section, and good luck on the quiz. Maybe.